Hi, everyone. Let's get started. I think we're on time. My name is Tom Manville.
Hello, my name is Ilya Kislenko.
And we work for a company called Kasten, whose goal is to help simplify the management of stateful applications. And today we're going to be talking about operators in production. So Ilya and I have a lot of experience writing operators. We've open sourced Kanister, which is an operator whose domain is stateful applications. And also our proprietary product, K10, has a few APIs, some of which are based on the operator pattern. So we've decided to use the operator pattern because it helped us automate and centralize our operational experience in one place in a way that is well integrated with the Kubernetes ecosystem. What we found when writing these operators was that it's very easy to get started. There's many projects within the community that will help bootstrap your project. But like anything in production, the devil's always in the details, and so there's a lot of kind of things that we'll go through that we experienced. The rule of thumb that we developed to try to figure out if our operators were production ready was to compare the operators to core Kubernetes APIs and controllers. By doing this, we were able to implement APIs that felt familiar to developers and also integrate with existing tools from the community. So today we're going to talk about how to extend the Kubernetes API for your operator. We'll talk about the requirements and features that we think are needed for an operator in production. And finally, we'll talk about the pain points that we hit when developing these operators. And we go through expanding the Kubernetes API. We'll define some terms and then go through some of the bootstrapping projects. And for that, I hand off to Ilya.
So, what is operator? You have an application which happily runs in Kubernetes, and you know about everything about that operation, about this application. Your DevOps knows everything, or your Ops people knows everything. Let's call it domain knowledge of your application. It works fine, but this is the time when you want to do upgrade, or it's time to scale down or change something. Pretty much what you want to do an action on your application, and you submit custom resource. What it is, I will tell you about a little bit later. So the controller, the code which lives inside the Kubernetes, sees the custom resource, does analysis, and then performs needed changes for your application. Sounds like magic? Not really. It's just an operator. So operator, domain knowledge, plus custom resources, plus controller. Let's talk about operator design pattern. When you're creating operator, you're literally moving human ops knowledge into software. Each operator follows three simple functions. It's observe or watch, just waiting for something to happen, then analyze what needs to be done, and then act on it. Gets back to the first step and watch for it. Following these three things, you can support really complex operations. Also, active reconciliation helps you to change application on really different ways and do it safely or not safely, depends on you. Also, operators are super extensive. Let's talk about what is custom resources, or to be specific, what is custom resource definitions. What the difference, what the similarity. In Kubernetes, if you want to create an object, first, it needs to be defined how it's going to look like. It's a little bit easy for core objects or in-tree objects because the definition is already there. So you're just creating pod or deployment or replica set. For the custom resources, first, you need to create custom resource definition, which literally defines new API. This is Kubernetes object. All of them cluster-wide scoped, which is important. We'll see a little bit later why. This is in-tree API, and it adds new endpoint to the API server. The custom resource, actually instance of the CRD, also Kubernetes API object. It can be scoped as the cluster-wide or namespaced, and it's out of tree API. Here's two examples. Our CRD is defining new stable example.com API group and the new kind of that group called cron tab. And our custom resource is actually instance of that custom resource definition, which is also kind cron tab, and it has some specs, the arbitrary JSON or YAMLs. It's a cron spec and the image. I'm getting back our presentation to Tom, who's going to talk about the API conventions.
So there are many types of APIs in Kubernetes, and using them all feels very familiar. The reason for that is because there's a set of conventions that all these APIs follow. And so to write a really robust production operator, we recommend you do the same and follow these conventions for your API. So this document is actually the document that lists the conventions, but I'll go through some of them right now. Kubernetes APIs are RESTful, meaning that these API objects are controlled through HTTP verbs like get and post. These objects are named and potentially namespaced. Together, these fields, name and namespace, form a unique identifier for every object in your system. There are other fields that constitute the metadata for each object. There are things like labels and versioning. Resource versioning enables synchronization, and labels enable ways to query your object. The Kubernetes API is declarative first, but can also be accessed through imperative requests. Most objects have a spec and a status field. The spec field defines the intent, your desired state of the world, and then the status field is updated by the controller to say what the state of the world is. So there's a lot of conventions, and it can be very difficult to implement these. Luckily, there's some help. So there's these tools called operator kits, which will help you bootstrap your project. A little over a year ago, when we started working on the Kanister project, there was 2 out there. So they're both called operator kit. One was released by Rook and one by Giant Swarm. Both these projects are built around the Kubernetes official Go SDK called Client Go. We ended up using Rook because it had more helpers to help you initialize your API. But it turns out that these 2 projects are not mutually exclusive. Giant Swarm has a bunch of libraries which help wrap Client Go to make it more robust and easy to use. Had we started working on these operators today, there are actually many more projects that have come out in the past year. So for those, I'll hand off to Ilya.
Okay, let's talk about new school of frameworks. There's 3 like the most popular, I would say. There's many of them, but we'll talk about only these 3. Number 1 is Operator SDK from CoreOS. From Red Hat. Actually, no, it's from IBM. And I checked 5 minutes ago, it's still IBM, we're good. And it's a really good Operator SDK. It has a really good community, a lot of talks, a lot of guides, a lot of support. And they also introduced really cool concept called Operator Lifecycle Manager, a pretty much operator for your operator. Let's do more turtles, because it's cool. And pretty much they're trying to answer the question, who's watching the watcher? Cool concept, probably useful in production. Another one is the Cool Builder. This is the child of SIGAP API machinery. Super opinionated framework. But if you love Go structs, Go types, this one is for you. Also a lot of code generation, and it's super close to actual Kubernetes API and how it feels like and looks like. And the last one is the meta controller. If you don't like Go for some reason and you want to write your operator in JavaScript, you can do it. And also you can deploy your operator in the really fancy way as the function as the service. You can do it. I will not recommend you doing it. I would encourage you to pretty much pick one of the Go-based operator frameworks. They work better. They're close to the Kubernetes API, and it will feel natural. So, as you can see, or as we described previously, bootstrapping is relatively easy. Let's see what it takes you to get into production. You just follow common sense and some best practices, which we will share a little bit, in a few seconds. Let's talk about clients. Clients is the way how you communicate with your operator. I would recommend you use the native ones. I will describe which one. RBAC. If you're in production, you need RBAC, period. Safety. Safety, it's not about safety. It's more like your operator should not harm your app. If it's not sure what to do, it should bail out. Do not break it. Events. I assume you're running Kubernetes in production because you're listening to the how to write operators in production. So Kubernetes in production, you probably have something like logging, monitoring, some event listening. So the way how you integrate your operator with those beautiful tools, you're using default events from the Kubernetes. That's the easiest way. Testing, production code needs to be tested. I believe it's obvious. Let's talk about clients. If you're using frameworks, Go frameworks especially, there's 100% guarantee that you're getting integration with the default clients like kubectl or some Go SDKs. Here's the example how you can create one of the easiest object in the Kubernetes namespace, the kubectl way and the Go way. Your custom resources will be the same way if you're using proper frameworks. If you're doing it from the scratch by yourself, you might get in trouble. So please use frameworks. RBAC. Everyone afraid of RBAC. I have no idea why. It's not that complicated, but it's a double-edged sword. You can prevent something happening, or you can allow something happening, so be cautious. Don't forget, users are not equals service accounts, which means you as the user can do things with the kubectl which probably your operator, which works as the service account, might not see. Learn from our mistakes. We, for some reason, made small tiny mistakes in one of the rules. We decided that CRDs and CRs are the same, which prevented our operator to listening anything. We spent 2 days of debugging that one. Remember, your operator at least should be watching CRDs and listening CRDs and getting them. And for the CRs, you can give all access or non-access. I mean, you probably need something like edit because you're going to update events. Please follow principle of the least privileges. If your operator doesn't need something to be called, do not use it. Use the least privileges as possible. It helps in production. And this note, back to Tom. Oh, sorry, my bad. Graceful changes. When I was talking about do not harm, you know when you're transferring knowledge into the operator, you should trust it. Because you're trusting your ops people, and they created operator, so it should work. But from the operator perspective, you should be really careful what you're doing. And when you're changing something or you're applying changes, do not break your app. Please. If you're not sure, do not apply. Also, we noticed recently that some operators think it's a really good idea to managing pods themselves. I would say it's not a good idea. Please use some workloads like deployments or the stateful sets. They have really cool features like stateful set, for example, always guarantees that your pods will be named in the predictable fashion. Also, if you're doing any changes, they will be in the order, which kind of hard to implement yourself. Also, all those workloads and objects from those workloads already tested by community, runs in production. Please use those. So, back to Tom.
Thanks, Ilya. So the bootstrapping projects that we mentioned earlier will help set up your code generation. Code generation is really useful for any Go developer. It will help you eliminate a lot of boilerplate code and will prevent adding new bugs from that code. So these bootstrapping projects will help you set up the core Kubernetes API generators. 4 of them are listed here. So Deep Copy Gen will help you generate functions. And then the other 3 help generate clients like the one that we showed earlier from Client Go. So using code generation is very easy. You use annotations. These are just comments above your Go structs. I have an example here which we pulled from the Kanister code base, but you can find examples like this all over the place. In this example, gen client just means create the clients. You can pass parameters to the generators. In this case, we pass a no status, meaning do not generate libraries around the status fields. And finally, the last annotation here says generate the deep copy functions to implement this specific interface called runtime.object. So eventing. Eventing is a really useful way to figure out what's going on with your application. Events are created on API objects, on other API objects. And so when you want to query them, you can describe that API object, and you get a list of some information about the object, but also the events that were created for that object. In this example here, the top snippet, this is from Kanister. So we have an API object called an action set, and if we describe that action set, we can see all the events that were created on that. Events are also API objects themselves, and they can be queried directly using kubectl or your favorite other clients. In this case, kubectl get events will list all the events in your namespace. Unlike other API objects, however, you cannot, they're not created in the same way. So because they're created on an API object, on a different API object, you have to use slightly different code to create them. So this snippet is similar to what we do in Kanister, where we create an event recorder in the first part, and then every time you want to create an event, you use the second snippet with that recorder on some object. So testing. Any production code should definitely have a lot of testing around it. If you're using the Go library, the Go native test framework is pretty powerful, but it is missing a few features. So some features it's missing include test suites and matchers to check the output of your code. Kubernetes uses a library called Ginkgo to solve this problem. Ginkgo is a behavior-driven test framework that allows annotations to describe the behavior you're testing, and if your test fails, you can determine exactly the behavior that is broken. So this is really powerful if you're trying to make robust tests. One trick that we use for testing our operators is to actually run the controller outside clusters. So typically when you run a controller, you instantiate the client configuration using in-cluster configuration. So the first snippet here is what you'll see all over the place, which is in-cluster config, which grabs the service account token that's mounted in every pod, and then we'll use that to instantiate a client. What we found is that we like to use clients outside of the cluster as well. So if you want to run, for example, a controller on your laptop, you have to use your local context to instantiate that controller. So the second snippet is how we do that. This snippet will actually, if you're running inside the cluster, it will use your in-cluster config. And if you're running outside the cluster, it will use your local kubectl context. If you want to have very fine-grained testing, you may want to mock out certain APIs. One cool thing about the generation code that we showed earlier is that it will generate a bunch of fake clients for you. And so in these snippets, we create a reactor. We create a reaction. This reaction will always create a new object. When we instantiate the fake client, we add this reaction, and we'll always return that fake object every time we do a get we issue a get to that client. Now back to Ilya for our paper cuts.
Originally, this slide was called Rage, but Tom said it's not appropriate. Now it's overview. So pretty much it's not rage against API machinery. API machinery is great. I actually love it. It saves a lot of times. It works, and it's great. But there's a small, tiny thing with it. When you're working with the core objects, they work just fine. But when the CRDs, there's actually gaps. And these gaps are sometimes annoying, sometimes can be dangerous, and sometimes we had a paper cut for that. So here's what we find out, and that's what we can share. Validation. You have to do things yourself. I will describe later what it is. Because, CRD lifecycle. Custom resources, as you remember, once you're creating that, before you're creating that one, CRD is supposed to be created. It's not the case for the in-tree objects, but it's the case for the out-of-tree objects. So who's controlling them? We'll discuss it a little bit later. Object versioning, in-tree, or the core objects are really good with the versioning clients. It's not the case for the CRDs or CRs. Getting better, but there's some gaps. And my favorite, Cogeneration. Cogeneration is amazing. It's super cool when you just run something and it creates things for you and it works great. Unfortunately, when we started using KubeBuilder, we spent a lot of time to set it up. And it was throwing some really interesting, weird errors. But once it started working, it's super useful. It's super great. Highly recommended. So, validation. You're responsible to validating whatever you're getting into your operator. What I mean by that. So, yes, OpenAPI validation will validate schema. So all the objects will be with the expected schema or predictable schema. But let's pretend, let's think about it. You using something like S3 bucket. And your operator is getting some name, and before actually work on it, you probably want to validate if the even S3 bucket name or URL is valid. Because Kubernetes has no idea if it's there or not. Yes, in tree objects or core objects, they have a really extensible, really good way of validating what's happening inside. Not the case for the CRs. Another way of validating objects, your custom resources is validating admission webhook. This is a quote from the official documentation. As you can see, they're quite dangerous, so use responsibly. But at the end, what's happening? You're trying to admit new custom resource, and you're getting called back to your operator to validate what's inside. So we're getting back to the first point. You're responsible for validating what you're getting. CRD lifecycle. As we know, CRDs are cluster-wide objects, which means everyone can access them, and there's only like one active version of them. So what's the problem with that? Someone has to manage them, because if you want to change schema, you want to bump version, what's happening? There's two ways how you're controlling it, and there's right now outgoing debate in the community how it should be done. There's a few ways and pros and cons. If you're using only one operator in your cluster, you probably want to control them from the operator. Because it's a little bit easy, less instrumentation, operator wakes up in the cluster, trying to get custom resources, don't find any, create new one, or update new one, and it just works. But if you have more than one, if you have 3, 4, or 5, it's a little bit tricky. If you update only one of them, the CRD version cluster-wide will be changed for all of them, which might lead to some errors. When you will try to act on the resources on the different version, they will just not work. Probably in this case, if you have many operators running, you want to control them outside of the operator by deployment or any other mechanism, CI/CD, for example. So when you're updating all your operators, you bumping version, changing version. So that's probably a little bit easy if you have many operators. Again, it's an outgoing debate. We don't know the answer, but we will find soon, I hope. Another small, tiny honorable mention. Be cautious on how many custom resource definitions you're creating. There's really great service mesh application called Istio. They're creating 50 custom resource definitions. When you're doing kubectl or get CRDs on the cluster, it might take really long time. And I highly encourage you to try the thing. Deploy Istio, do kubectl get CRD minus v9. That thing is amazing. Back to Tom.
Thanks, Ilya. So another big issue we hit when developing our operator was custom resource versioning. So custom resources have a different versioning scheme than core API objects. One thing we did initially was we'd have constant schema changes to our API objects. This caused problems if there was existing objects in the cluster already that had different schemas. Things would break in kind of random ways. Luckily, in Kubernetes 1.11, they added support for multiple versions for custom resources, which is really good. However, the support is still relatively limited. The conversion between different versions of these objects is very simplistic. They call it the no-op, or basically a pass-through conversion. Luckily, there's discussions around kind of adding more advanced conversion code, as well as adding specific validation for each version of your object. So we definitely look forward to those. So in closing, we have a few suggestions for you. Definitely follow the API conventions. It'll make it much easier to integrate with the tools in the community. The best way to do this, we think, is use one of the bootstrapping projects, and probably a Go one so that you can integrate with the rest of the Go tools. We recommend you generate your code so you can avoid rewriting the same code over and over again. For production features, definitely use RBAC for security and events to understand the state of your system. We suggest you invest in your testing. And we also suggest you use the techniques we mentioned around operators in this talk. Beware of the gaps between the core API objects and the API extensions. There's definitely a few of them, and they can cause some issues. It's important to remember you're not alone, right? This can be hard, but the community is very helpful. We're certainly willing to help. Reach out to us on the Kanister Slack or tweet at us. And so with that, we'll take questions. We actually have some swag, so if you ask a question, you get you get a nice bag which you can hold other swag in. So ask away. Thank you.
I'll be the muscle.
Sure.
Thank you. My question is, what do you mean the gap between CRD and the core APIs? The gap mean what?
So there's some features that exist for core API objects that don't exist for custom resources. So if I write a CR, for example, there's conversion code for core API objects. You can't have that conversion code for your CRs.
Thank you.
Yeah. No. It's my fault, bad throw. Yeah.
Thank you. I have a question. In the OpenShift 3.11 and the etcd operator and Prometheus operator managed by the operator lifecycle manager, and do you have a plan to to manage your operators by the operator lifecycle manager platform developed by the Red Hat.
Thank you for the question.
Yeah.
The actual kit that we used for the newer operators was KubeBuilder, but we're definitely willing to try other bootstrapping kits. And I think the one you're referring to kind of integrates well with the operator SDK. Is that accurate? Yeah. So we actually haven't used that for any of our operators, but it's definitely a great option if you use that yourself. So, thank you. Way in the back.
Yeah, I see.
You see him here.
Can you share some experience on how to canary deploy your operators or do some beta release of your operator? Because operator, we can only have one running operators, even we have maybe 3 replicas. So deploy a operator may be very dangerous.
Definitely, that's a great question. So unfortunately, we have to, the way we do it is we use different clusters, especially because these CRDs are cluster scoped, right? And that is kind of an issue. And I think I did hear some chatter about namespacing CRDs, but I actually don't know the details on that. So, but that is a great point. I think there's maybe not a great solution that I know of right now. So.
Thank you. My question is, you mentioned there are 2 options for the CRD lifecycle, right? First, it's in the controller, and the second is during the deployment. There are also a kube builder. So the logic in the kube builder is the option 1 is create the CRD in controller, right?
So KubeBuilder actually creates CRD YAMLs for you. And so it's up to you to deploy those in your cluster somehow before running the controller. And so that's really the option where you kind of do that during deployment, or really before your controller starts running. The alternative is you could actually instantiate and give your controller permissions to create the CRD when it starts up and ensure that it's the correct version. But the KubeBuilder approach is actually to do it before running your controller. Thank you.
So,
I have a quick question. So it's like a best practice. When the controller gets deleted, is it how should I say, like, is there like normal to also delete the customer resource definition, or just leave it there?
So we definitely choose not to delete the customer resource definition. If you delete the CRD, then all the CRs in the cluster go away. And you can imagine, rescheduling of your controller, like, just the kube scheduler can move your controller around to different nodes, for example, or doing upgrades without wanting to delete all the CRs in your cluster. So we choose not to. You could imagine an API that would require that, but for us, our code, we don't delete the CRDs when the controller gets deleted.
Okay, thanks.
Yeah, thank you. And feel free to come grab a bag if you ask a question. Cool, thank you.
that's it. Thank you so much.
Yeah, thanks guys.